Assalamualaikum and a very good day. So class, now we are in week 11, which is for today we will cover the topic chapter 4, still under matrices. Subtopic here involve matrix transpose, determinant of the matrices, which consists of determinant of 2 by 2 matrix, determinant of 3 by 3 matrix, and also matrix inverse. First, we go to matrix transpose. What does it mean by the transpose of the matrix? If you have here a matrix M times N, transpose of this matrix means that you will change row as column and column as row. Because of that, for the transpose of the matrix, you will got here N times M matrix. That is, it is obtained by interchanging the rows and column. The transpose of the matrix A is denoted by A T, which is T here is stand for transpose. In this case, because here we change row by column and column by row, so if let's say we have here a matrix A equal to A, B, C, D, then for the transpose of this matrix A will become here A, B, that is from here it is row, but when you transpose it become column. And also for this one C, D, and original matrix this C, D it is row, but when you transpose it become column. Then we go to the theorem or properties of the transpose of the matrix. If A transpose is the transpose of matrix A, then if you add two matrices, then you take a transpose here. It is equal to you transpose this matrix separately. There is A transpose plus B transpose. If you have here a matrix transpose, then you transpose it back, it will get back the original matrix. Now we go to this example 1. Given the matrices W, X, Y, and Z here, find the following matrices if exist. So for A up to G here, you can do it by yourself because this example is exercises for previous lecture. But now I will go to H. So how can we solve this H? We are given here, our W is given by negative 205, negative 3, 2, negative 1. So if you want to transpose this one, for this H, we will got here W transpose will be equal to our row become column and column become row. So in this case, we will have here negative 2, negative 3, 0, 2, 5, negative 1. So if you see this one, originally it is row, but now it's become column. And for the column number 2, originally it is row number 2, but now it's become column. So this is how we can get our matrix transpose for this W. Now we go to example 1J. In this case, we need to find Y transpose X transpose. Before we solve this multiplication of these two matrices, we need to take transpose first. So our Y transpose here is given by a matrix 2, negative 1, 3. Because now our row, our column become row and our row become column. For X transpose here, we have a matrix 1, 0, 4, 1, 3, 1. So when we want to take Y transpose X transpose, means that it is 2, negative 1, 3. We need to times with a matrix 1, 0, 4, 1, 3, 1. In this case, we check first dimension of the matrix. For this Y transpose, it is actually 1 times 3 matrix. For this X transpose, it is 3 times 2 matrix. Means that when we solve this one, we'll got here a matrix of 1 times 2. So for this case, it is exists. The solution for this multiplication of the matrix exists because you can cancel out this 3, then you can get 1 times 2 matrix for the answer. So how to solve this one? Now, we need to multiply this row by column here. Okay, so in this case, we will have here 2 times 1 plus 4 times negative 1 plus 3 times 3. And then for another solution, which is at second column, it is 2 times 0 plus negative 1 times 1 plus 1 times 3 or 3 times 1. So when we solve this one, we'll got the answer 7, 2. The solution for example 1 is given by all these. So you can do this one as your exercises, then you can double check the solution. Now class, we go to this example 2. Given here A, B and C matrix, we need to find 1, 2, 3, 4 and 5 here. So we start one by one for this case. For case number 1, you need to find A transpose. So A transpose here means that, remember, your row become column, column become row. But now you have only one column, so this one will become one row. So we have here 4, 3. And then for number 2, we need to find B transpose. So in this case, we'll have 2, negative 3, 1, 7. For number 3, we need to find C transpose. So in this case, we'll have the answer 3, 2, negative 2, 4, 1, negative 6. So now you can see this one is matrix with 1 row times 2 column. This B transpose is 2 times 2 matrix, and this one is 3 times 2 matrix. Originally, we have here 2 times 1, 2 times 2, and this one is 2 times 3. Okay, and then we check here for number 4, we need to find A transpose B. So in this case, our A transpose is 1 times 2. B transpose is B is 2 times 2. So in this case, you can multiply these two matrices. That is 4, 3 times 2, 1, negative 3, 7. You'll got here, for this one is 1 times 2. This one is 2 times 2. Means that your final answer here should be 1 times 2. So in this case, when we multiply these two matrices, we got here 4 times 2 plus 3 times negative 3. And then 4 times 1 plus 3 times 7. That is our solution here, 8 minus 9. So this is negative 1. Here 4 plus 21, which is 25. So this is the solution for number 4. And then you can do it by yourself for number 5 here, which is for number 5, B, C transpose. In this case, our B is 2 times 2 and our C transpose is 3 times 2. If you see here, dimension for this one is not equal with this one, so we cannot cancel out. So in this case, we are unable to multiply these matrices, means that there is no solution.